My name is Ramona Jackson. I'm an IT director in IT operations at Cisco. And I'm going to just kick us off and talk a little bit about a success story that we've had this past year leveraging Splunk technology. I'm going to start my story 2 years ago, actually on my first day in IT operations, which was Halloween of 2012. About 9 o'clock that night, one of my employees called me on the phone, one of my new employees who I'd spoken with one time prior to that, and let me know that we had a situation in one of our data centers, and I might want to join a telephone bridge for a few minutes to listen in on the troubleshooting. So I dialed into the bridge, joined a chat session online, and for the next 9 hours, I observed the troubleshooting that was going on. So at 6 a.m. the next morning, the phone call ended. And so after I took a nap, I spent some time reflecting on what I'd observed during that lengthy time of troubleshooting, at which point there were at sometimes more than 50 people on the phone trying to figure out the problem, or what was the cause of the problem that we had. I'm sure some of you have experienced that before. And we continued that activity over the next few weeks as I was getting into my operations role. And I kept sharing feedback with my team. And we looked at all the process areas that we could address and so on, and we did everything, we exhausted everything we could to make that troubleshooting and getting to the root cause of problems process better from a people perspective. And what we saw over time was our metrics looked something like this. We'd have good months, good quarters, bad quarters, where we looked like we were doing things well, and then we realized we really weren't there yet. And so about 10 months ago, we huddled together with some key technical folks in operations and looked at what are opportunities out there that we could address. What data did we have available to us? What were our machines telling us that humans could not solve? And that's when we came up with this concept of leveraging Splunk data and other data from other machines and correlating it together to help us pinpoint the cause of problems. And I'm going to bring some technical guys up right now on my team that have put together a capability that we feel like has really transformed the way we do IT operations at Cisco.
Thanks. Thanks, Ramona. My name is Kiran Kulkarni. I'm an IT architect with the performance. Is it better now? Okay. My name is Kiran Kulkarni. I'm an IT architect with the performance management group in Cisco IT. Primarily, my department takes care of the performance of any applications that gets deployed onto production. So what we'll do in the next 25-30 minutes is look at how it got started based on what Ramona mentioned. We'll just look at how it got started, what's the high-level architecture, and then we'll look at the powerful visualization experience that we created. I'll cover the non-ERP footprint. Sridhar here will cover the ERP and some of the capabilities that the tool can provide. So we'll keep it light and crisp. I'm going to go on to the, okay. So one of the key reasons what we realized that any incident or any problem that we see in production is because of the complex application footprint. And I'm sure this resonates with a lot of your applications in your data center. For one particular business transaction, there are several integration points that an application needs. And we are not even talking about the cloud here. This is pretty much what in-prem kind of an implementation. So what we realized is, now this is only the logical aspect. What about the physical aspect? You have infrastructure, you have compute, you have hosting, you have storage, you have network. And it starts becoming more and more challenging as we try to resolve an incident. So as we embarked on this journey of EventPro, the tool that is, what we did was we started putting together dependencies. We wanted to realize what the application touch points were. If an application becomes slow, We don't know, is it because of the application itself, or is it because of any of its touch points? So we wanted to realize that, put everything together on a single pane in sort of dependency. What we also did, and this was pretty interesting, we actually looked at the last 6 to 8 quarters, the incidents that happened in production. And what we realized, had we had a proper dependency footprint, and had we acted upon these symptoms that these applications exhibited, we could have prevented them. And surprisingly, more than 55% of the incidents that we gotten in production all fell in the high bucket. We could have prevented these incidents. So what got us started were these two key elements. One was to look at dependencies. The other one was to monitor each and every component that make up the footprint. Now, is that enough? Definitely not. If we are not able to correlate what my database is saying versus what my application is saying, or what my storage is saying, there is no way we would be able to avoid the time that it takes to diagnose the problem. So what we did was we started looking at how do we build the dependency map? Do we have all the data to construct end-to-end representation of an application? And application is a very loosely used word. Application could mean a JVM, application could mean a VM. But do we have all of that data? So when we started working with key architects in their space, we were able to pull together data sources that actually made up for all the dependencies. So we looked at provisioning. Now, provisioning told me where the application is running. Is it running on a VM or a physical host? And then we looked at profiling information. So in real-time production, what is the characteristic my application exhibits in terms of connection? What databases does it connect to? Between databases, what is the relationship? And thirdly, configuration played a very key part. So in Cisco IT, everything goes through a proper configuration or a deployment topology. So we do have the configuration files that tell the application what are its touch points. In a way, what messaging service do they connect to? What web services do they connect to? What databases do they connect to? What schemas do they connect to? So we took that information as well. And then we took all the log files, application logs, hosting logs, VM logs, all the log information that would help us in constructing the dependencies. What platform did we address? We looked at a lot of platforms. We looked at IBM WebSphere, Oracle WebLogic. We looked at Oracle databases. We looked at messaging and web services. We looked at the Oracle OBIE, Informatica, Teradata. We looked at a lot of platforms. So now we had a wide array of data sources that actually talked about the dependencies that could be established in the platform. The other part of it was to establish what metrics are we going to look for. If I were to look at health of my application, what are the metrics that we need to look for? So in a way, what happened now was we were able to capture the dependencies, we were able to capture the key metrics, but the important part was correlating it. We did not want a database saying that there is no problem, but an application saying that there's a problem because of it connecting to the database, because database probably can handle much more traffic or much more volume. So we wanted to correlate it. We wanted to tell the user, or we wanted to tell the support teams that if there's a problem in the database, or if there is a problem in the storage, your application could also get impacted. So We built out an in-house correlation engine, and most of the correlation today happens in Splunk. And with that, what we created was a visualization platform. So this visualization platform gives you an incident prevention experience. So the visualization platform doesn't stop just at the screen, but you also get notifications. You get alerts. So tomorrow, if you're not looking at your screen in terms of visualization, no problem. You'll still be able to act upon it because you do get notifications. So with that, what we did was we built out a product called Event Pro. And quickly looking at the high-level architecture, we have several data points. Data exists at several places. Provisioning information exists in a database. The messaging information exists in a database. We have web services. We have layer 7. So the web service data exists totally different in a different platform. Then, of course, you have the infrastructure stack, the VMs, the hosts, the physical hosts, the pods, the clusters, and the storage. So what we did, we pushed all this data into Splunk, which is our raw data indexer, if you will. So based on the data that goes in there, we created summary indexes onto another Splunk instance. And from there is where the visualization derives the data. So that's pretty much the high-level architecture. And if you were to look at the Splunk architecture, this is our enterprise Splunk. And these are all our enterprise indexers. So what we built out for Event Pro is these are our non-enterprise Splunk instances, which have their own local indexers and search heads, and the visualization, which we'll shortly get in, derives the data from this. So for the visualization aspect, we leveraged a product called Perseus. Perseus has a booth next door, I believe. So Perseus gives us the visualization not just from a canvas perspective, but also from integration into other products. I can integrate Perseus into Splunk. I can integrate Perseus into homegrown dashboards if somebody wanted to take a look at deeper data or raw data. So with that, I'll go over to the demo. I don't know how is it. It's fine. Okay. Event Pro follows a service-oriented organization structure. So what does that mean? All the business functions in Cisco are mapped as services. That becomes the outermost ring. And then you start putting in your logical business functions that are related underneath it. So you go from a service category, which is the outermost, then you go in, you get a service offering, and then your services and your service assets. So what we tied up is applications and to their service. So today, if I wanted to report out a health of my service, I can do it because it gives me an ability to summarize all my asset data. So let me just zoom it a little. So I'll pick one non-ERP service category, which is Cisco Commerce, which is our commerce platform. So as I mentioned, Cisco Commerce is our service category. And we have all the services, the pricing service, the quoting service, which are all the logical business functions that is needed in supporting the commerce platform. So on this screen, where you see the green dot, I can pretty much click there, and I can get the assets and their performance and availability or the health metrics. Okay, so this particular service has 3 assets underneath. They're all Java applications. It tells you what is the availability and what is the performance deviation in terms of the health of the particular application. Now from here, you can go down into looking at your asset information. So it gives you a detailed breakdown of all your assets. So now if you click on individual asset, you would be able to get the key metrics. What are the health metrics, or what govern the performance and availability of this particular application. So we have some specific to Cisco metrics in here, but it is pretty generic enough that tomorrow, if we wanted to add additional data to it, the platform is robust enough to accommodate that. So it gives you a kind of a breakdown. This is a P1 application. So we don't see any availability violations. We are seeing a minor performance deviation to a tune of -2%. It runs in two different data centers. No hung threads, no markdowns, no restarts, no alerts as such. So this application is doing fine now. We talked about the dependency at the very beginning. So where does that tie out? So this is my footprint for this particular application. So it's very obvious that for the purpose of a single business transaction, it is going to talk to several of these. Probably not all. Depending on the scenario, it might do branching, but otherwise it needs to talk to a wide array of services. So we built out, sorry. Okay. So this is the health metrics of the database. So now where does the event correlation or the correlation aspect that we talked earlier come into picture? The database is seeing some IO related issue, but it has not impacted your application health. So that is where we make a distinction of whether we need to do a proactive alert or a predictive alert. So in this case, it is more of a predictive alert that if somebody doesn't act upon the database, there could be a problem. If my application already started degrading, then is where we send out a proactive alert. Now, one other aspect is, we call this as data center on canvas. So what this gives you is an ability to visualize the entire physical footprint of the application, all in one single pane. So this gives the support teams a lot more ammunition in terms of who they need to page. They don't have to call anybody randomly now. They know if there is a problem, for instance, the red blip here, it says that there is a load check on a Linux box. So they know that they need to involve the respective hosting team or the compute team. They don't have to call in an application person to come in onto the bridge and then troubleshoot. So this mainly cut out our MTTD, mean time to detect, and thereby the resolution became faster. So one key aspect of this entire framework that runs underneath is dynamic. So tomorrow, if you were to add a couple of databases, new databases, we recognize it. We'll get it onto the screen. You don't have to do any manual work. And we follow 80-20 rule for primary platforms. Everything is auto-detected in terms of the dependencies, what I should be looking for. How do I construct the dependencies? There are cases such as Informatica or Oracle ERP, which is, again, a very big footprint. That's where we need some manual intervention because the dependencies there are more logical and they don't go with a physical configuration or provisioning kind of a framework. The beauty about this canvas is it gives you ability to switch to the context that you drill down on, but the entire canvas is rendered. In other words, when I clicked on this database, it just showed me the database aspect, but you had the entire screen which had the physical infrastructure information about my application. So with that, oh yeah, thanks, Sridhar. So the integration points that we talked about with Perseus, I'll quickly go in. So from Perseus, now you can get into Splunk to view the raw data. It might take time over the VPN, but nevertheless, I'll just leave it. And it also gives you an ability to go into your own dashboards. For instance, we have a database dashboard. So we have a custom database dashboard built out, so it gives you the metrics. So the beauty is we can integrate it with any product, any third-party product, in-house product. With that, I'll hand it out to Sridhar to walk us through the other aspects of the visualization and the ERP stuff. Sridhar.
Hi everyone, my name is Sridhar Billa. Can you guys hear me okay? Excuse me. Can you? Yeah. Hello. Can you hear me okay? Can you hear me now? Okay. Hi everyone. My name is Sridhar Billa. I work with Cisco, obviously, right? So, yeah. Okay. No, that's fine, I guess. That's fine. I think they already registered it. Can you try this one? Can you hear me now? Okay. My name is Sridhar Billa, and I think Ramona and Kiran touched base a lot of things on it. So I'll just quickly try to explain on the ERP piece of it and kind of try to give you some demo on that. So a couple of years ago, I was here at .conf, and we've been looking for some type of monitoring tools for the ERP components. ERP is, again, the database, and then the Splunk, and then the visualization piece. I think finally we were able to achieve that. So in Cisco Commerce is our external-facing online application where you can capture the orders. But once the order comes into system, we process everything through ERP. Either it is an ordering process or the fulfillment process or invoicing and general ledger and all. So for that, what we have done is just like the way we have the overall service portfolio, you can see here we have the order management and the supply chain management and many other functions, right, in finance and everything. Based on that, we have the service categories, service and service offerings. As Kiran was saying, right, in case of ERP, we have an 80-20 role where we have some type of manual mapping. And based on our service portfolio, we were able to map the corresponding concurrent programs of the ERP to just to map, because once we have the concurrent programs, and we'll be able to get to the concurrent managers on which databases they run on, which nodes they run on, and which host they run on, so that we can start monitoring those aspects. So that's what we have done here. So I'll just give you one quick example on from order management point of view. We can see within order management we have different business processes. Processing a service order will have a different flow than processing a product order, because service we may not fulfill or we may not ship the order, right? So based on that, we have different workflows and whatnot. And so if I just take an example of service process hardware order, and then again within that we may have many different functions, and everything is tied to the concurrent program, and not necessarily concurrent program. We have Java applications and whatnot, but I'll focus on the concurrent program. And what we have done is, if you look at this workflow background process, I hope this may be more familiar for most of you. This is a process which will move the order from one stage to another. If you look at either Amazon, you can see the order status, right? It is booked or shipped and whatnot, right? So this is the engine which does that activity. So if I look at it, and this is the workflow background process, and if I just click on this, the dot there, and it will display all the concurrent programs which are running for that business function in different databases. We may have multiple databases. But this is where we captured a lot of information, either using homegrown application or the third-party applications. So for example, workflow background process is running on different databases. We get the request ID, we get the instance name, argument, the parameters, or what is the current status. It is running now normal, and you can see, again, these are all kind of customizable, whatever we want to monitor. These are the key metrics we wanted to monitor. The username, SID, of Oracle, again, it is a backend, the process ID, when it started. And these are the metrics, kind of we captured here. What is how long it has been running, and what is the threshold value? The threshold value is basically based on our kind of defined thresholds based on some algorithms and whatnot. We have some more information, like what is the average runtime of that program, or the minimum and maximum, and things like that. But again, it is not just displaying this information, right? Once we have this, we'll be able to, like for example, you can see, again, you can see green, yellow, and red here. It is based on the thresholds. What does it mean for us? Red means obviously, it crossed the threshold. And what do we need to do? What do we do? First of all, based on the Splunk, the search and alerts, we send out alert based on if it is yellow or red to the respective support team, so that they can look into it. And this is becoming, before it becomes an incident, right? So this is where the proactive aspects come into picture, right? So once the alert goes to the support team based on the thresholds, and again, thresholds can be adjusted, and the support person can go and see, okay, what's happening? Okay, this request is showing red. So if I just click on the request ID, it will open up either it is a Splunk or any other third-party dashboard where we can see more information about that particular request. In this case, I just clicked on the request ID, and you can see that what is the request ID, what time it started, and it will give the SID also, Oracle SID, and some more information to be able to debug what is going on. Similarly, we have SID also, and that will kind of pinpoint more information about that particular process. But also, it will give you a lot more information, why the program is running, or why it is showing red. Is it because, are there any locks on for that program or the corresponding tables, or is there any issue on the overall database level? So you can see a lot more information. Again, this is customizable for us. And with that, I'll kind of drill down further. You saw some the logical view as well as the physical view. And you can see on the logical view, this is a program which is running on 3 different databases. Metrics are loading. Give it for a second. Here we kind of also captured some of a common stack. Either it is I think in case of the WebLogic WebSphere, you would have seen a lot of access management type of things. Here we kind of try to capture the concurrent manager aspects. We can see again the same metrics what you had seen in the earlier screen. But you can see, right, so this is red, CG1 PRD, but there is no red on the CG1 PRD on the database layer. That seems to be fine. The host is fine. Locking, there are no locking issues, no undo read and wait events and IO. So everything seems to be fine. So this will kind of help the support teams to go and try to find what is the problem. And in some cases, it could be purely based on the transaction volume. So there may not be an issue also, right? That is where we have to see, do we need to adjust the thresholds or as a normal, or do we need to be alarmed about it? So I think on the physical view you've already seen. So I'll skip that. That is where we have the Splunk integration. And with that, so this is mostly about the ERP piece. This is where we were able to connect. It's not only ERP. I think the point is that it could be ERP, it could be Teradata data, it could be any other source where we are feeding that either through XML or whatnot into Splunk, where we are indexing everything there so that the Splunk can use that as a single source for the visualization. Otherwise, we have, I think, most of you in your companies also, right? There is no shortage of monitoring. We have tons of monitoring, right? But we have monitoring for database. Maybe we have OEM or host monitoring or whatnot. But how can we consolidate everything together? So this is helping us, either using everything feeding into Splunk, doing the searches, consolidating, and then giving that visualization using the Perseus. So this is the kind of a high level, but the concept is it could be Oracle, ERP, or it could be any other source. So just to show that the capabilities here. A couple of other features. What we have here is that we have a playback mechanism. I'll just go back to the home screen first. Then we have a playback mechanism where, say, issue happened a couple of hours ago or yesterday. Do we know what happened? Sometimes we may not be able to go back, right? But this is helping us to go back and see, kind of play back what happened. So you can see the screen here, playback, and we can define the timelines. It could be, I could go back yesterday around the same time, or I could, and also I can change the interval for the playback. Either it is a 5-minute or 1-hour interval, and I can go and do the playback. So kind of it helps us to go back and root cause, in case of like after the fact. So that is kind of one functionality we have here. And if I can go to the report section. So when we play back, and we'll be able to generate the reports, because sometimes we may have to show it to the executive management and see what happened, or to share with other folks. So here kind of we have one report we just saved. Again, it is a little bit older date, 27th August, but we had some incident there. So you can see what happened, and you can see just give it, yeah. So you can see some of the beacons are going off, red, yellow, all over the place. But then we could go back and drill down into it, see what's happening. Is a database issue, or what was going on? So that is another functionality, and we can go through that. So kind of that is pretty much high level what we have. I think Perseus has a booth here, and you can here I think it is not doing the full justice actually, especially from the resolution point of view. If you see it on your computers or on screen, it looks much prettier. And you can play around there when you go to the booth. So that is kind of an overall, kind of a high-level summary. We'll take the questions, but I'll have Ramona just do the closing thoughts on.
Thank you, Sridhar. Thanks, Kiran. So just a couple of closing thoughts, and then we'll certainly take some questions if you have them. One of my teams is responsible for monitoring Cisco's data centers, all of our applications 24/7. We have 3 command centers located around the world. And this product that these guys have developed has really changed the way we do our jobs. And we've seen just in the past 2 quarters of leveraging this technology, we've seen our business impacting incidents go down by more than 50%. And I'm sure that trend will continue to go in the right direction. We're very confident about that. So just some lessons learned for us. Always on is the new normal for us. That's our goal, is to keep our services up and running all the time. And operationally, this is one way we can certainly support that. We've still got some things that we're building into the product and the technology based on our metrics that we capture on a quarterly basis. We do a lot of lessons learned activities and do some research into those metrics. And one other thing is that I've learned through this, especially with getting up to speed with Splunk over the past year, is that we know more than we think we know. And there's enough data out there from machines that really will allow us to be a very sound operational organization. So I think now we'll take questions if anybody has them.
Yeah.
Do you know about how many hours you have in development of this solution?
How many man-hours went into development of this? You wanna?
You go ahead.
So we took about 4 months to bring this solution into production.
With the group.
About 4, 5. Yeah. So I think development of this product is one aspect. When we operationalize it, there is also a process aspect to it. So there is a big team that does the process aspect of it, as to how do we read the alerts, who are the people that we need to contact. So there's an orientation that goes in on the process side as well. Yeah? Yeah. It's an in-house built process. So the question was, does the tool do the auto dependency, or it's an in-house? It's an in-house correlation engine that we have written. Yes.
Is that engine in Splunk?
Yes, the engine is written in Splunk.
Have you guys run into a situation where these, when you set the alarm or alerts based on thresholds, at some point of time it becomes noise, and the person who is supporting the app quits paying attention to the events going.
Yeah.
So there are thousands of them coming on.
Yeah. So I don't know if you heard the question, but in gist, how do you control the noise in terms of the alerts that are being generated? So for ERP, we have some sort of a static threshold, and that you can tweak it with a percentage based on, let's say you run into a quarter end or a year end. So you can say, allow 10% more deviation during some of these extended timelines. But for most Java application, the threshold is dynamically built. So it goes through, it does a sampling on dynamic basis. It looks at what was your application SLA today, yesterday, a week back. So it auto adjusts based on what the availability was. So in other words, we look at what the application performance was and we autocorrect along the way.
Is that being done in Splunk?
Yes. Yes. So it's an adaptive. So the way it works is it tells you that there is a potential that there could be an incident, right? So as we progress along this path, we have other items that we are adding to the roadmap in terms of incident, bringing on the previous incident or even your change management data into it. But today, it doesn't auto-create your incident, but the facility is there. We haven't turned it on. We are still grappling up with controlling the noise. We don't want too many incidents to be open. So that feature is there, but we haven't yet turned it on. Yes. Correct. So the question is, how do you incorporate the environment changes? For instance, it could be adding a VM, or it could be moving my application from one VM to the other. So based on the data source, we poll these information every so often. It could be 10 minutes, it could be 24 hours, depending on the platform. And we reflect it back onto the UI as well as onto the alert. So our source of truth will get adjusted based on what the changes are. There could be certain network changes that might not get seamlessly integrated into this, but most of the day-to-day activities, yes, it auto-corrects.
Two questions. Number one, is that visualization a fat client on a PC or is it web browser?
So today the visualization is a desktop client. So the plans are in place to move it to a web version. By end October, we are going to do a POC on the lighter version to see how it performs, because the thick client gives you a lot more features which may not come out in the web version. So we are taking it. Yeah.
Okay, and the second question is, who all do you give this visualization to? Is it only to the ops team or even to the developers?
So today it is primarily to the ops team and the application support teams. So in other words, if I am tied to a particular service category as a support person, I'll get an access. But the developer, it is totally up to the service owner how he wants to give the access or control the access. If they want it, probably the developer can also get it. Yeah.
So I think one key thing we missed to mention, right? So this is giving the complete end-to-end picture of the whole Cisco applications, and this is very good view for the executive management, especially to see what is happening in the portfolio and do they need to be worried about or to be alarmed about. So it is not only the developers and the operations, but the management and the executive management, as well as the business users as well.
I'll let Ramona answer that question.
Funny you should ask. We actually are just launching the next phase of that and looking at that and working with some of our product marketing organizations right now to see what's feasible. So yes, we are looking at doing that. I'll give you an overview. I'm not sure how much I can say, Brian, but I'll be careful. But we just had our fiscal year end about 3 months ago, and our goal was to get this rolled out to support that financial close process for us, which is a 3-week period. And we are very confident because we have reporting and data to let us know what we prevented, and we are very confident that we prevented 19 incidents during that 3-week period. Now, what level of severity they would have been, I'm not certain, but we know that we prevented some critical problems, potential problems during that 3-week period. Does that answer your question? Okay. Do you want to give them an example? Of something we prevented that would have been catastrophic? Yeah.
Sorry, I'll answer that, but you're saying something. Sure. So the question was, can we give any examples of the previous incidents which we prevented? As Ramona was saying, right, during the quarter-end, we had, obviously you'll see a lot of fluctuations. Quarter-ends, we generally see peak volumes of orders coming in, many users are logging in, whatnot. But that helped us to see the spike in either the memory usage or some lockings. So there are multiple scenarios, as Ramona was saying, right? We prevented about 19 issues. So the different flavors are, it could be, the memory usage is going up or the load on the system. Sometimes locking issues. So, but we were able to jump in and then engage the right infra support teams and address that before it becomes a P1 incident where the whole application was down, right? If we did not have this, we would have found it, but maybe much delayed version or maybe after the fact. So if that helps. Yes.
So where do you track state for that map noise alerting? Is that something where Splunk is feeding state data to EventPro and it's like flipping good bad? So EventPro is actually the engine behind the state management.
Yeah. So most of the backend engine is Splunk, everything, right? So the Perseus is giving the visualization piece, all alert, but everything, the backend is all Splunk.
And then Splunk feeds into EventPro, which then manages your good bad.
Yes. Yes. So, could you repeat the question? Sorry, we couldn't hear. No. Could. So the question was, do we have multiple instances of Splunk? So as Kiran was showing in the slide, right? So we have the enterprise implementation. So that is collecting a lot of data from a lot of sources. So we did not touch that because for EventPro, we wanted to create its own. So we're kind of basically taking the data from that and aggregating it for the visualization piece. Does that answer your question? So we developed on our own. We have some algorithm, but again using Splunk. So we kind of not sure if we can reveal all the details on the proprietary, but basically, we look at say last 4 weeks data on a given day, given week, given hour, and we capture all that information. And so today, it's 5:30. What was the right? Yeah, it's all everything in the on the Splunk. Yeah. Thanks. Any other questions? Yes.
Yes. So it is pretty much it does detect which data center you're running it on, which cluster you're running it on, yes. How is it doing it? So basically, we get the provisioning information as to a particular application running on a VM. We know from the hosting team, again, that's also a provisioning information, what is the cluster that it is running on. So all we do is to correlate both. So if tomorrow, let's say the application moves on to another cluster or let's say to another node, your data source gets updated. And we take the same data source again and update it in Splunk and then represent it back onto the UI. Yes. Yes. So the predictive aspect of it is pretty much what we got in as tribal knowledge, knowing our applications. So we know exactly how the applications behave during a certain time frame. So a lot of predictive techniques were baked in with tribal knowledge in mind. We haven't used any algorithm per se, but a lot of algorithms in the industry which do the predictive techniques, it's somewhere close by. Yeah. Sure. Yes, we do retrain the model, and in fact, the engine that it runs, it pretty much does the autocorrection on the run. So a lot of course correction happens dynamically. Yes. Yeah. So, so the question is, are we using cluster? Is the Splunk instance cluster aware? No, it is not. If no other questions, we all head to happy hour. Thank you.